Okay, so how about, let's take a look here. Now, what's our first step? Where everybody needs one of these sheets? Where's got them? You need one? Actually, yeah, I'm not good. All right. Need one of these? Okay, so first step, what do we got? We have a picture, right? Say it again. Yeah, we need to, at this frame in the movie, right? We got this balloon that's rising up in the air. At this frame in the movie, what are the values of all of the variables that we've got there, right? So what do we know? Okay, x is 150. Good. X is 150 meters. Good. What else? So that took care of this one, right? That number. X dot is positive 10. We know that the balloon is rising at a rate of 10 meters per second. So therefore, x is changing at a rate of 10 meters per second. And that takes care of this. What about the 200? Is that a variable? Oh, that's constant, isn't it? That's this distance right here. The camera is 200 meters away from the point where the balloon is rising, right? Okay, so that's going to stay 200. And we've got that written on our picture as a number, so we're okay. So those are the two variables we're given. What are we being asked about? Rate of change of theta. Good, so we're looking for theta dot. Okay? So there are our snapshot values of all the variables. So what's the next step then? Say it again. Well, I mean, yeah, we might end up finding theta too. You're right. We can always add some. We might add some numbers up here too, some values of variables. But now we've established that our variables are x's and x primes or x dots and theta dots. We've got to come up with the parent equation, right? The static equation that doesn't have any dots. And that's the one that we can then differentiate to get the dots, which is literally the process of relating the rates, right? We want the rates of change to both appear in an equation that relates them. So if I blur my vision and ignore the dots, I've got x's and thetas, so we need an equation involving x's and thetas. What about that y? There's a y in the picture. It's tempting, yes, tempting to want to use that, but we really don't. We want to minimize the number of variables, right? We can possibly just keep this between two variables. That's nice, and we can't. So the y is superfluous. Don't need it. What's our equation then? What do you think?
I'm not sure if this is right, but theta is equal to arctangent of x.
That's correct. That is a correct statement of the relationship. But do we know how, at this point, do we know how to differentiate an inverse tangent? We don't. So although that is a correct equation, we want to restate that in a way that gives us an equation that we can differentiate. So how could we restate that? Okay, we could just write in terms of a tangent, which we can differentiate. Okay, so then our equation becomes tangent theta equals x over 200. Okay, there's our static equation. Now we can do some calculus on that equation. And what do we get? If I differentiate that, and what am I going to do here? I guess I jumped the gun. You guys tell me, when I say differentiate, what am I differentiating with respect to? Time, because we want dots there. And remember, a dot means a derivative with respect to time. So if I differentiate with respect to time, what am I going to get on the left side? Okay, good, because first I've got a tangent of something. Derivative of tangent is secant squared something times theta dot, sure. If I look inside the tangent, I've got a theta, and the derivative of theta with respect to time is my theta dot. Okay. On the other side, okay, do I need quotient rule? No, I don't. I mean, I could, but it's gonna be a big waste of time. How come I don't need quotient rule there? The quotient rule really means you're taking the derivative of a quotient of functions, right? And there's no, the bottom's just constant. So I could just think, if I want to, I could even physically pull that 1/200 out in front. That's just a constant. The only variable there is x. So what am I going to get if I differentiate with respect to t? Yeah, 1/200 times x dot, because we're not differentiating with respect to x, we're differentiating with respect to time, right? So on this side, we're just going to get x dot over 200. Does that make sense? Okay. All right. So there's our derivative. Now, all we have left to do now is just isolate the theta dot and plug and shove, right? Okay, this is where there's kind of a neat little trick that comes up. If I isolate theta dot, what do I get? Couple cool tricks. Okay, x dot, and I'm going to divide by secant squared, so over 200 secant squared theta. Can anybody tell me a nice little, maybe a more convenient way of writing that in terms of a trig function? Yeah, reciprocal of secant is just cosine, right? So I could write that as cosine squared theta x dot over 200. Okay, what's the problem with that answer? Yeah, we don't have a theta. Now we got a couple of options. Somebody help? What could we maybe do there? Oh, okay. Sorry, I was. That's right. Okay, so I could take the arctangent. I could go back to that static triangle back here. And here's my picture. If I fill in some numbers, we know that x is 200. 150, right? It's a right angle. So I could solve for theta by using my arctangent. I could actually come up with a number for theta, right? Or even, I probably don't even want to write it as a number. I just want to leave it as arctangent. And then when I put that in my calculator, I won't lose any rounding there, right? So I could go up here and solve for theta and just call it inverse tangent of 150 over 200. And what I've written there is just a number. Does everybody see that? When I say the arctangent of a number, that means a number. It's like saying sine of 30, and I know that that actually means a number, right? Okay, that's one way to do it, and I can just plug that into my answer. There's another way that's kind of slick that I want to reacquaint you with, maybe. If I've got a right triangle like this, I can use the right triangle as what's called a reference triangle. And I can just, if I were to solve for all the sides of the right triangle, if I know all three sides of a right triangle, can't I write any trig function of that right triangle as just a ratio of two sides? Including, what do we end up with, cosine, right? So if I just fill in the blanks, I've got 150 and 200, and all I have to do is just find the hypotenuse, which is easy to do. 250, okay, because we just got a 3, 4, 5, don't we? So that's, it's 3, 4, 5 times 50. So this is just 250, we get nice clean ratios. And if I come back down here now, so if I know that's my right triangle, what is the cosine of theta equal to as a ratio, SOHCAHTOA ratio? Say it again. 200 over 250? Sure. Okay, so cosine theta equals 200 over 250, which reduces to 4/5. Okay, that's kind of slick, right? Now I can just take that ratio and substitute that down here for cosine theta in my answer. Okay. So we end up with cosine squared theta is just 4/5 squared. X dot was 10, wasn't it? Divided by 200, that's my answer. We'll turn it into a number, but that's how you do that. Okay? Make sense? All right. Why don't we